In this lab station, we're going to take a look at how the elements chlorine, bromine, and iodine react in order of their reactivity series. And we're going to do that by seeing how well those chemicals react with the compounds sodium chloride, sodium bromide, and sodium iodide. To help the reaction be seen a little bit better, we're going to be testing for the elements chlorine, bromine, and iodine when they dissolve in the chemical hexanes. So we're basically going to check for a chemical reaction, and then we're going to see what color that reaction product turns in the chemical hexanes. The first thing we need to do is take a look at the individual chemicals themselves. So the first one we're going to take a look at is chlorine. Now on the periodic table you'll notice that chlorine is a gas, but in this sample right here I've dissolved that chlorine gas in water. So you're first of all going to want to write down your observations of what that chlorine water looks like. These chemicals often smell like the odors that you'd find at a swimming pool because they often use chlorine chemicals or bromine chemicals to disinfect the water. So if you're watching this video, you won't be able to smell those fumes. But again, what we're trying to do is keep those fumes to a minimum. So we're doing this experiment under a lab vent fan, and we're also closing up those chemical bottles as soon as possible. Now what we need to do is to check for what chlorine looks like when it dissolves in hexanes, which is a flammable organic solvent. So I'm going to add a squirt of the hexanes. Hexanes is non-polar, so it's not going to dissolve in the water, so it's going to form a different layer, and because it's less dense, it's going to float on the top, and the water that the chlorine used to be in is going to be on the bottom. So if you look at the test tube, you should be able to see those different layers. Again, it's the hexane layer which is on top, and the chloride water, or the chlorine water, is what is on bottom. I'm going to add the test tube and gently invert that, shake it to get that chlorine to go up into the hexane layer. And now when you take a look at that top layer, you want to write down its appearance. You'll notice that it's both colors were pretty much clear. The chlorine water is pretty clear, and the hexane water is fairly clear. If the chlorine water was a little bit more concentrated, it would kind of have maybe a slight yellow or a green color to it, just like you'd see if you opened up a bottle of bleach at home. The next sample we're going to take a look at is bromine water. And on the periodic table, bromine is a liquid, but it easily vaporizes. And I've taken that bromine vapor and dissolved that in water. So that's what we're going to take a look at next. So I'm going to add a squirt of the bromine water to a test tube, and we'll write down our observations. You'll notice all of these chemicals, the bromine water, the chlorine water, and the iodine water, have to be stored in brown bottles because they're fairly reactive substances, and they tend to break down over time when exposed to light. So again, this is our bromine water sample. You want to go ahead and write down your observations on the color. And again, what you can't smell right now is that there are some strong bromine vapors in the air. So again, I did put the cap on the test tube. And as those bromine vapors leave the bromine water, once I add the hexanes, they're going to travel up into that hexane layer. And you also want to write down what color that hexane layer is. So again, you can see the hexane layer is the layer on top, and the bromine water is the layer on bottom. I'm just going to gently shake that up to allow that bromine to go up into that hexane layer. You can see as I shook those two samples up, the bromine definitely went from the bottom up into that hexane layer, and now you can tell that that top layer has more of the bromine in it. It's a much more deep, darker orange color, and the bottom layer lightened up because it no longer has as much bromine in it. Alright, the next element sample we're going to take a look at is the iodine water. Iodine on the periodic table is a solid, and it's a purple solid, but when you dissolve that iodine in water, you get a distinct color. So the problem with this is iodine has a very similar color to bromine. So again, the whole reason we're adding that hexane layer is to try to find the difference between these two chemicals. So I'm going to go ahead and add that hexane layer now, and hopefully we'll get a distinct difference between the bromine and the iodine, so we know what we're looking at as we do the experiments. Alright, so you can see the hexane layer is the layer on top, and the iodine water is the layer on the bottom, and I'm just going to mix those two layers up, giving the iodine some time to work its way up into that hexane layer. And as we did that, you can immediately see that that top hexane layer is a very different color than that bromine layer was. So this hexane layer is kind of a pink or magenta color, and that's the test that we're going to use to find whether we're looking at bromine by itself as an element in the lab, or whether we're looking at iodine by itself in the lab. So again, if it turns a magenta layer, that means that the iodine is by itself.